Kia ora. In this STAT193 video, you're going to learn to use your graphics calculator to calculate small sample confidence intervals for the difference between two means. Experimenters gave a set of tests to a sample of 9 and 10-year-olds. Each child was given an aerobic fitness test and classified as being in one of two groups, either lower or higher physical fitness. Each child also did a memory test and a memory score was recorded. Here are the results. So we've got the two groups here, the lower physical fitness and higher physical fitness, the sample sizes for each of the groups, the mean recall score for each group, and the sample standard deviation for each group. In this problem, we're wanting to calculate a 99% confidence interval for the difference in means between the lower physical fitness group and the higher physical fitness group. To do this using our graphics calculator, we go into the Stat option of the main menu. We choose interval, which is F4, and we've got the choice between Z and T. In order to make this decision, we need to consider the sample sizes of each of the groups. Now, because at least one, and in fact both of them, are less than 30, we can consider this to be a small sample, and so we're going to use T. This is making the assumption that the samples come from a population which is normally distributed. So F2, we're interested in a confidence interval for the difference in means, so we choose 2S, which is F2. We check that data is on variable, and if it's not, we select F2 to change it. For the confidence level, we look at the confidence interval that we're being asked to calculate, a 99% confidence interval, so we enter 0.99. We then need to enter the sample mean and the sample standard deviation for the first group, so that's that there. And the sample size for the first group, which is 16. And we enter that similar information for the second group. Now we've got a choice here of having pooled on or off. So this is asking us whether or not we want to use the pooled variance. So we can either allow for the variances of the two populations to be different, in which case we would turn the pooled variance off, or we can assume that they are equal, and in which case we turn it on. In this example, we see that the variances are close to each other because the standard deviations are close together. And so the assumption of equal variances in the two populations is quite reasonable. So we're going to have pooled variance on, which is F1. Now we can execute that, and what we get here is the left and right bounds of our confidence interval for the difference between the two means, our degrees of freedom, and we can see the information, the sample means, the sample standard deviations are here, so we can double check that against the problem here to make sure we've entered everything correctly. It also gives us SP, which is the pooled sample standard deviation, which is here, which we may need to report, and our sample sizes. Right, coming back up to the confidence interval bounds, the way we report this is that a 99% confidence interval for mu1 minus mu2 goes from negative 19.13 to 14.83. So the left bound here comes from this left number here, rounded to 2 decimal places. If we round this one, 14.83 to 2 decimal places, it gives us this right bound here, and a confidence interval is most easily reported by putting it between brackets with a comma in the middle. One thing we just want to notice about this confidence interval is because it goes from negative to positive numbers, we're including 0 in this confidence interval, so 0 is a believable value for the difference it means. So this confidence interval gives us no reason to doubt that the two means are the same.